Now we will go to the question how partial differential equations arise. The partial differential equation will arise when we want to remove arbitrary functions or arbitrary constants from an equation. Okay? That means the answer is one option, by removing arbitrary constants, and the second option is by removing arbitrary functions. Okay? Now let's take example for by removing arbitrary constants. Example by removing arbitrary constants. Okay? Let's take an equation that z equals to ax plus by plus a square plus b cube. Okay, here a and b are arbitrary constants. A and b are arbitrary constants. And z is dependent variable. Z is dependent on x and y, and x and y are independent variables. Now, differentiating partially with respect to x, we get del z del x equals to a plus 0 0 0. So del z del x equals to a. Again, differentiating partially with respect to y, differentiating partially with respect to y, we get del z del y equals to 0 plus b plus 0 plus 0. So del z del y equals to b. Now we will replace this information. In this equation. So the equation becomes z equals to a is del z del x, so del z del x into x plus b is del z del y, so del z del y into y plus a square should be del z del x whole square and b cube should be del z del y whole cube. So this is the equation, and this equation is free from arbitrary constants from this equation. And when we try to remove arbitrary constant, we will get the equation where partial derivative operators are present. So the partial differential equations will arise when we remove arbitrary constants from equation. Okay? Now we will go to the the example of by removing arbitrary functions. Now we will go to the example by removing arbitrary functions. Let's take f of xy equals to x square plus y square plus z square. Okay, where f is an arbitrary function, okay, f is an arbitrary function and z is dependent variable, z is dependent on x and y, and xy are independent variables. Now differentiating partially with respect to x, we will get f dash xy into y equals to twice x plus 0, because y is independent variable and that is constant for this case, and twice z del z del x. Okay, now differentiating again, differentiating partially again with respect to y, we get f dash xy into x equals to 0, because x is independent variable and it is constant here, plus twice y plus twice z del y. Now these we call 1 and this equation we call 2. Okay, now we will remove the arbitrary function. So for removing we have to divide 1 and 2. So dividing 1 by 2, we will get f dash xy. F dash xy is removed, y by x equals to twice x plus twice z del z del x by twice y plus twice z del z del y. Now 2 is removed from the numerator and the denominator, so the equation becomes y by x equals to x plus z del z del x by y plus z del z del y. Now we will simplify this, y square plus yz del z del y equals to x square plus xz del z del x. So this is the equation where partial derivative operators are present but no arbitrary functions are present. So when we remove an arbitrary function from equation, the equation of partial derivative operators will arise and we call them partial differential equations. Okay, so partial differential equation will arise by two cases. First case by removing arbitrary constants, and the second case by removing arbitrary functions. Okay,